Today we're going to talk about using and finding inputs when given outputs. So remember that independent variables are your input and dependent variables are your outputs. So one of the things you may be given is an equation, and you have to manipulate it or rearrange the equation so the x is the independent variable. Now remember, they can use any variable they want. They can use a and b, x and y, s and t, whatever variable they want. And when they ask you to put it and rearrange it for whatever variable independent, that means that has to be within the rule. So for example, this one, if we want this one to be the x is independent, it has to be the part in the rule. So we think about it as like f of x equals whatever our rule is. Or we can think about y equals whatever our rule is. So we want to manipulate this one to be so x is in the rule or independent. So we can take and move it by subtracting x on both sides. We have 4y equals negative x minus 52, and then divide by 4 on all pieces. So we end up with y equals negative, there's a 1 there, whether we see it or not, negative 1/4 x minus, and we think, can 4 go into 52 evenly? Well, 4 can go into 5 one time with 1 left over, and 4 can go to 12 3 times. So this would be our equation rewritten, rearranged, so that x is the independent variable. Let's look at another example. So we're going to rearrange this one so x is the independent variable. So before we do that, we're going to go ahead and distribute. So we have 3x plus 6 equals y minus 7. And if we want x to be the independent, remember it has to be within the rule. So we're basically solving for y. We're solving for the dependent. So plus 7, we get y equals 3x plus 13. This would be our function rule with x being independent, y being the dependent. Now, like I said, they can use other variables. So this one uses m and n. And it's telling you that n is the independent. So I want to solve this for the independent. So I'm solving so that the independent, the n, is in the rule. So that means I've got to get m alone. So plus 2n plus 2n, I have 3m equals 2n plus 12. And then I'm going to divide all my pieces by my coefficient of 3. I got m equals 2/3 n plus 4. So this would be my rule with n being the independent because it's within the rule, and it's solved as m equals, or the output equals the rule. Now, you're going to be given some outputs, and you're going to use that to find the input. So the way these would look, here's our function rule, f of x equals 2x plus 3. And I want to solve for x, so I want to know what x is, what the input is, when f of x is 3. So f of x being 3 tells me that this is the output. This is what I get when I put something in. So I already know what f of x is. So I'm going to replace over here f of x with what I know is 3. So 3 equals 2x plus 3. And I'm solving for what x is. So minus 3, get 0 equals 2x, divide by 2, divide by 2. Anytime I divide 0 by a number, it's still just 0. So x is 0. And I can check to make sure that's right by plugging it back in. 2 times 0 got me 0, plus 3 gets me 3. And that was what my output started as. So let's try another one. So here's our rule. G of x equals negative x minus 3. We're going to solve for x, so we're solving for the input when we know that the output, g of x, is 10. So this is our output. So we're going to replace g of x here with negative 10. So negative 10 equals negative x minus 3. And we're going to solve. So plus 3, a negative 10 and a positive 3 gives me a negative 7 equals negative x. I don't ever want to have a negative variable, so I'm dividing by, remember there's an imaginary 1 there, but it's there. We don't write it because it's not necessary to write. We know it. So divide by -1, divide by -1. This -1, -1 turns into a positive. I'm left with just x. And negative divided by negative is a positive, and I'm left with 7. So my input is 7 when my output is -10. So we can double check. Negative x minus 3, that was our rule, g of 7. So when our input is 7, let's see what it would be. So g of 7 equals negative, that's part of the formula, use our parentheses, 7 minus 3. Well, negative times a positive is a -7 minus 3. Two negatives, we keep them together, find the sum, keep the sign, -10. So I know it works. Now, you're going to do the same thing when you have graphs. You can be given the input. So this one, you know the input. So this is some dots on this graph. And it says the graph of y equals fx is shown. So we got little dots. So these are some points that could be on our function. It says, according to the graph, what is f of 1? So when you're given f and you know the number that's there, this is the input. Okay, so our inputs are always on our x. So we're going to go to where it's 1. And that's where we're going to see what would help us. Oh, a is right there. And what would y, our output, be? Well, it would be -5. So when our input is 1, our output is -5. So you did some of these the other day. So now let's look when we have the output on a graph. So here's our points. It says f of x is 5. Notice that this is not a number in there, so we don't know our input, but we know whatever we put in there equals 5. So we know our output. So we can think about this as a coordinate pair. We know 5. So we need to find what our input is when our output is 5. So our outputs are always on the y, so we're going to go up here to 5. And we're going to look then across and see, oh, well, D will work. And D is when we're at 2. So our input would be 2. Okay, let's try one more. So here's some other points. We've got f of x is 3. So that's telling us our output is 3. So outputs are on our y. We can think about our coordinates. Output is 3. What is our input to make the output 3? So we're going to look, here's 3. We're going to look across this line. D is helpful, and we're going to look down to where our input would be, which would be -3.